All right, today we're going to expand our discussions of volume and surface area to include figures that have no bases. We've already worked with pyramids and prisms, but now we're going to look at the only shape that we're going to look at in geometry that doesn't have a base, which is the sphere. Okay, we've already got a definition of sphere, but we haven't really worked with any of the math around it. Okay, so far we've looked at surface area and volumes of figures that do have bases. Today we're going to look at the only figure we'll cover in geometry that has no base, the sphere. Okay, basic vocabulary, I would expect you to know 2 of these terms, but the third one might be something new to you. Okay, radius and diameter should be nothing new or out of the ordinary. But when it comes to spheres, we have a new term that's called the great circle. Okay, the great circle. Has anybody heard this term before? It's probably new to us. Okay, and basically, just to kind of put it in as plain English as possible, the great circle is the largest circumference that a sphere is capable of producing. So of course the great circle will change sizes as you get larger spheres or smaller spheres. But for each individual sphere, the great circle is the largest circumference that the figure can produce. And to kind of put it into plain everyday type terms, if you think about the equator of the Earth, the equator is basically, for all intents and purposes, it is the great circle. It is the widest across that the Earth will be. All right, there are 2 formulas that go along with the sphere. Pretty cut and dried type formulas. As is the case with circular objects, we only really have to bring one piece of information to the table in order to calculate either volume or surface area. Because there's only one piece of information that makes a circle do what it does, or makes a sphere do what it does, and that one piece of information is the radius. So in order to calculate the volume of a sphere, it has a coefficient. The coefficient is 4/3, and then it's pi r cubed. This is a formula that you will find on your formula chart, so you don't have to worry about memorizing it. We just got to know how to use it. And the surface area is found by, again, a coefficient. This time it's only 4, and it's pi r squared. And if you think about that, of course, you got the coefficients are different. They both have pi in them. Okay, all of our circular formulas have pi in them. Okay, you've got the radii in there. The volume formula, the radius is cubed. Surface area, the radius is squared. That makes perfect sense when you get to thinking about it, because what dimension is volume in? It's a 3rd dimensional measurement, right? So its radius is in the 3rd dimension also, radius cubed. Surface area, okay, you got radius squared. What dimension is surface area in? 2nd dimension. Okay, that's why you get radius squared. Okay, so from here on out, basically all we are looking at is the ability to utilize these formulas. So we're going to start off with a pretty straightforward example, and then we'll move into something a little bit more complicated before the day is out. Okay, but let's start off with this one. Find the surface area and the volume of a ball that has a diameter of 10 inches. Now you can fully expect on problems like this where there's only one variable to plug into the formulas, that being radius. You can fully expect that they are probably not going to come out and hand you the radius. They're going to make you do some kind of work in order to figure out the radius. Okay, and just depending on how cruel they want to be about it, they can hide it a number of different ways. This is probably the simplest of all ways to hide it. They're going to hand us the diameter instead of the radius. Okay, so that's easy enough. But let's start off with surface area. We have a formula for surface area. So you go to your formula chart, you'll get your formula for surface area, you'll bring it back to your paper, you'll write it down, 4 pi r squared. Okay, all we have to do, like we said, all we have to bring to the table is the value for radius. So have a look at your problem. Do we know what the radius is? Yeah, they didn't hand it to us, but it's simple enough. What is the radius? It's going to be 5 inches. So there we go, single value, plug it in. This is about as easy as we could hope for. And this is where we would most likely be going to our calculator to figure out what 4 pi 5 squared is. Okay, so grabbing our calculator, okay, we've got this value 4 pi times 5 squared. It's really just as a matter of typing it up. Okay, so just go 4 times. If you're not in the habit of using the pi value, it's programmed in the calculator. You might as well just use it. It's on top of the caret button right there, that little rooftop looking guy. And then, of course, you've got 5 squared. It's 25. Okay, and we come up with a value, 314.16. And surface area is a second dimensional measurement, so we're talking in square inches. Okay, really not a big deal. And it's really not much more difficult of a problem to work the volume, other than the formula simply looks different. But again, it's a formula that's on our formula chart, so we'll go to the formula chart, we'll get 4/3 pi r cubed, we'll bring it back, we'll put it down on our paper, and once again, all we have to know is radius. Well, you already told me that the radius was going to be 5. Okay, so once again, we just have this number, whatever it is. Okay, let's figure out what we got. 4/3, that's just 4 divided by 3. Okay, pi, there's pi. And 5 cubed, if you don't know that 5 cubed is 125, what you can do is you can ask your calculator to do this for you. And the way you would do that is you put your base in, whatever it is, 5 in this case. Use your caret key right there underneath the clear button. If you're not familiar with that guy, what that does is that raises one number to another power. Okay, and we're going to raise 5 to the 3rd power. Now, depending on which BIOS version we have in our calculators, it may not actually write it as a superscript the way my calculator did. It may actually just show you the little rooftop caret symbol in the screen and then put a 3 after it. But in either case, you got 4/3 times pi times 5 cubed, and we get a value in the area of 523.60. And there it is, and volume is 3rd dimensional, so we're talking cubic inches. Now, very nice if the problem is nice enough to come out and hand us radius, which I would not bet on them doing. I also would not bet on them handing you the diameter and then going about the problem. My bet would be that the radius will be hidden in some more complex information in such a way that you will have to get it out of what they gave you in order to then plug it back into one of your other formulas. Okay, so let's look at a problem that's going to deal with things a little bit differently. This is probably more of what you can expect from an end of course question. If a sphere has a circumference of 25 centimeters, find its surface area. Okay, well, just like any other problem, probably our first step is to decide if we have a formula that will accomplish this and what kind of information that formula will need. Then we can start to figure out if we have everything that is required in order to work the problem. Okay, so we're looking at surface area of a sphere. So we go to our formula chart and say, okay, I need surface area of a sphere. You look it up and you would see that surface area is 4 pi r squared. Now, it's a circular question, so the only information that we're going to have to bring to it is the value of the radius. Okay, so we can look into the problem and go, okay, radius, are you in the problem? And the answer is no. The radius is not provided for us in the problem. What is provided for us, the only thing that's provided for us, is circumference. Okay. Well, now it becomes a question of, well, since I cannot actually solve the surface area that they wanted us to solve, I guess I better figure out what I know about circumference. Okay, well, what do we know about the circumference of a circle? Does it have a formula that goes with it? Okay, what is that formula? Remember? Okay, well, it's also on the formula chart. Okay, so we'd go to our formula chart and say, okay, I need the circumference of a circle now because it's the only clue I have, the only lead I can follow here. And you would find that circumference is 2 pi r. Okay, now you may be looking at it going, hey, I've got the exact same problem here as I had with surface area. It's asking about radius. And you're right, it is talking about radius, but we're not actually trying to solve for circumference. Okay, we're not trying to figure out how big the circumference is. They told us how big the circumference is. Okay, so we're going to plug into this formula, but we're plugging into it in a way that we might not be totally used to. Usually when we use the formula for the circumference of a circle, we are using radius to figure out circumference. Well, if they gave us circumference, can we plug it in and then figure out radius? Absolutely, right? There's only one variable left in our problem, and it is radius. If we can solve for the radius using the circumference formula, then we'll be able to plug back in over here and find surface area. Okay, so let's see what we need to do. We need to get radius by itself. Okay, so what's going to happen in order for radius to be by itself? Yeah, the 2 doesn't need to be there. It's attached to our radius, and the pi doesn't need to be there either. It's attached to our radius. How are they attached? Yeah, they're being multiplied, right? We've got 2 times pi times radius. So if we want to move the 2 over to the left and the pi over to the left, how do you have to move them? What's the opposite of multiplication? Division. If we divide the whole thing by a 2 and divide the whole thing by a pi, that'll cancel out the 2 on the right. It'll cancel out the pi on the right, and we will simply have our radius equals whatever this number is. Well, let's figure out what this number is. We'll go back to our calculator and go, okay, calculator, I need to know what 25 divided by 2 and divided by pi is going to give us. Okay, and in this case, we've got this number, it's in the ballpark of 3.98. Now, the question a lot of people have is, can I round off on this like I just did? 3.98, is it good? Okay, and the answer to that is always the same in mathematics. Be very careful about rounding off in the middle of a problem. Because when you have a problem that's a 2-step problem or 3-step or who knows how many steps, if you round off early and then use that rounded off value and start plugging into other formulas, then your answer starts getting further and further and further away from the right answer. And that concerns me, especially on like a gridded question where you have to write in your answer and bubble it in. Okay, if it's one of those questions, if we stray too far away from the right answer, that may actually cause us to miss it because of a round off issue. Okay, but anyway, okay, we've got this value. Now, is this the answer to our problem? Radius equals 3.98. Is this it? We put a box around it, we're done? No, this is not the answer to the question that they asked, right? The question is about surface area. We got sidetracked over here on the right side of the board because when we tried to find surface area, we had insufficient information. Now, we do have sufficient information. We can plug in and find out what the surface area is actually doing. Okay, so let's have a look. Get a little more space. We have a value for radius, okay, and I warned you just a moment ago, it's kind of dangerous to round off in the middle of a problem, okay? Well, here's the value for the radius, and I know that this value wants to be squared, and I also know that I don't want to round off too early, so actually what I'm going to do is I'm just going to square this number. I'm not going to round off and then try to plug it in. Okay, all I'm going to do, and if you don't know this, or if you're not aware of this or not, okay, whenever you have a number waiting in there like we've got right now and we have not started the next line yet, anytime you hit any operator on the calculator, it's automatically going to do that operation times whatever the last, or do that operation by whatever the last answer was. Okay, so if I know I need to square that radius, I can just hit the square button, okay, and it's going to say ANS, and ANS is answer. And if you have lost it or whatever, there is an ANS. I believe it's on top of the negative key. I can't really see it, but I believe it's the second function on top of the negative key. Anytime you want to pull back the previous answer that you just found, all you have to do is hit second answer, and it'll pop that ANS up there, and it will use the previous value, including all of the decimal points, even the ones off the side of the screen. Okay, but there's our radius squared, which also needs to be multiplied by pi, and also needs to be multiplied by 4,
And look what you got. You got 4 pi r squared. That's surface area right there. Hit enter. What have we got? 198.94. Sounds like something. Did we have any units of measure? Get out of my way, calculator. Centimeters. What dimension is our answer in? Second dimension. Area has length and width, but no depth. So 198.94 square centimeters. Okay, and this is pretty much what I would expect the problems to do to you on end of course. They're not going to hand you radius. They're probably not going to hand you diameter. What they are going to do is they're going to conceal the radius in a different measurement. Like maybe they're going to conceal it in the great circle. Maybe they're going to conceal it in surface area. Maybe they'll conceal it in volume. Okay, they're going to provide you with some calculated piece of information like circumference did here, and then ask you to find a different calculation. So you have to get the radius back out of their calculation in order to put it into the next calculation. We'll do one more. There's not really much I can do for you on this except just guide you through a couple and turn you loose on it. If a sphere has a surface area of 1,000 square feet, what is its volume? Well, just like before, we're hunting down a calculation here, volume. So we'd go to our formula chart and see if we have the formula for the volume of a sphere, and we do. And it's 4/3 pi r cubed. Okay, so once again, like any other circular item, the important information is radius. So we look at the problem and go, okay, problem, did you bring us the radius or not? And the problem did not. Okay. The only piece of information we seemingly have to go on is surface area. So we go, okay, I'm going to quit worrying about volume here for a little while, and I'll start worrying about surface area and see what I can figure out that direction. So we go, okay, what do we know about surface area? Well, we go to our formula chart. Surface area for a sphere is 4 pi r squared. Okay, once again, it wants the radius in order to calculate the surface area, but we are not calculating the surface area. Surface area was already provided for us. So we're going to use what they provided us, 1,000 equals 4 pi r squared. Now we have an equation where the only variable that is there is radius. We should be able to solve for radius. And once we have that value, we can plug it back over here on the left and calculate the volume. Okay, well, let's look at what we have here. We got radius over there on the right. It's got a whole bunch of junk attached to it. Okay, the first thing I see is we've got 4 pi r squareds. We don't want 4 of them. I'm going to divide that 4 out of there. We got 4 pi r squareds. Well, we don't want pi of them, so we're going to divide that pi out of there. That'll take care of the 4 and take care of the pi. And that will leave us, and you don't even have to simplify this mess yet. So I'm not combining anything. I'm just rewriting it a little bit. And the last thing, in order to get r by itself, is we've got r squared. Well, we don't want r squared. We want just r. So how do you get the square off the r? That's right, square root. Okay, so we'll take the square root of both sides. That will get the square off of the r for us. Okay, and at this point, we got a big ugly number over here on the left side of the problem. So let's see if we can get our calculator to help us out with the big ugly number. Okay, we have the square root of, I've got 1,000 in the numerator, and then underneath that I've got a 4, and also underneath that I've got a pi. Okay, now notice the way the calculator works this. It looks a little strange to say 1,000 divided by 4 divided by pi. If you just put 1,000 divided by 4 pi, okay, the calculator is going to do the division of the 4, but then since there's no other sign coming after the 4, it'll automatically assume that's multiplication. It'll kick the pi back up to the denominator. So you either need to do double division signs on there, or perhaps even put your denominator in parentheses. Open up some parentheses, divide by parentheses, 4 pi, close the parentheses, so the calculator knows that entire thing is underneath the fraction. Okay, so unless I've done something wrong, this ought to bring us a radius, and we get something just slightly larger than 8.9. Okay, but again, we don't want to round off, okay, too far too early. Okay, now we got a radius value, but of course radius wasn't what we were trying to solve. We're trying to solve for volume. But now we have the value for the radius. Okay, so we can plug this in to the formula that we've got for volume. So let's see what we got. There's our radius, that 8.92062, blah, 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 over there. Now, according to the volume formula, that radius length needs to be cubed. So that's what I'm gonna do. I'm gonna start off with this guy and say I'm gonna take that answer and I'm gonna raise it to the third power by using the caret button over there. Okay, so there's the answer cubed. And what else will that need? It'll need to be multiplied by pi. It'll need to be multiplied by 4, and it'll need to be divided by 3. There's that coefficient, 4/3. Okay. So now, assuming we haven't done anything wrong, we ought to get a volume out of this thing, and we get this 2,973.54. And what kind of units were we working in? We were working in feet. And what kind of a dimension is volume in? Volume is three-dimensional. It has length, it has width, it has height, all at the same time. So there you go. And like I said a couple of times already, this would be my bet. This is how they're going to come at you with a sphere question if they bother to ask one. They're not going to hand you the radius, probably not going to hand you the denominator. They're going to turn it into a two-step question by concealing the information about the radius inside of another calculation like they did here with the surface area, and then make us get the radius out so we can calculate volume. That's pretty much all they can do to you with these things. Of course, there's some other things in there. The great circle is another place they can put it in there, but that's circumference. They can hide the radius inside of the volume, make us get it out of there to find something else, and so on. Okay, so we're going to need to practice some problems to get better at this, and that will be that.